For motors with the nameplate full load current, or FLC, of 100 amps or less, the maximum fuse size permitted by NEC Table 430.52 code is calculated as follows: fuse ampacity equals 125% times FLC. For motors with FLC above 100 amps, the maximum fuse size permitted is fuse ampacity equals 115% times FLC. Yes, this unit would be considered MOCP as it has time delay fuses in the service disconnect switch and no supplemental overcurrent protection devices such as overload relays. To calculate the MCA, or motor circuit ampacity, we use the following formula: MCA equals 1.25 times FLA, where FLA is the full load ampacity of the largest motor and 1.25 is the multiplier for time delay fuses. In this scenario, the largest motor FLC is 7.1 amps, so the MCA equals 1.25 times 7.1 amps, which equals 8.9 amps. Fuse ampacity equals 115% times 8.9 amps, which equals 10.2 amps. Therefore, the recommended fuse size for the service disconnect switch is 11 amps. The National Electrical Code, or NEC, provides guidelines for the safe and proper sizing of electrical components, including fuses, to protect electrical systems and equipment from overcurrents. Overcurrents can result from various factors, such as short circuits, ground faults, or excessive loads, and can cause damage to equipment, insulation, and wiring, as well as create fire hazards. Fuses are overcurrent protection devices that are designed to interrupt the flow of current when it exceeds a predetermined level, thereby preventing damage to the electrical system. The NEC specifies the maximum fuse size permitted for different types of electrical equipment and applications based on factors such as the equipment's full load current, the type of motor, and the presence of other overcurrent protection devices. The fuse size should be selected to provide adequate protection against overcurrents while also allowing the equipment to operate normally without nuisance tripping. When selecting fuses, it's important to consider the type of fuse. Time delay fuses are designed to allow short duration overloads, such as those that occur during motor starting without tripping. This type of fuse is commonly used in motor circuits to prevent nuisance tripping caused by the inrush current of the motor. Instantaneous trip fuses, on the other hand, are designed to trip very quickly in response to an overcurrent, providing more immediate protection against short circuits and ground faults. The NEC provides specific requirements for the use of time delay fuses and instantaneous trip fuses in different applications. The MOCP, or maximum overcurrent protection, is the maximum fuse or circuit breaker size permitted by the NEC for a particular electrical circuit or piece of equipment. The MOCP is intended to protect the equipment from damage due to overcurrents while also allowing the equipment to operate normally. The MOCP is typically determined based on the equipment's nameplate information, the type of motor, and the presence of other overcurrent protection devices. The NEC provides tables and formulas for calculating the MOCP for different types of electrical equipment and applications. The MOCP, or Motor Circuit Ampacity, is the minimum ampacity of the conductors that supply a motor. The MCA is calculated based on the motor's full load current, the number of motors in the circuit, and the presence of other loads. The NEC provides specific requirements for calculating the MCA for different types of motor circuits. The MCA is used to determine the appropriate size of conductors to ensure that they can safely carry the motor's current without overheating. The NEC also provides requirements for the overcurrent protection of motor circuits. Motor circuits must be protected by overcurrent devices such as fuses or circuit breakers to protect the motor and the circuit from damage due to overcurrents. The overcurrent protection devices must be sized according to the NEC requirements based on the motor's full load current, a type of motor, and the presence of other overcurrent protection devices. The NEC also provides requirements for the disconnecting means for motor circuits. A disconnecting means is a device that can be used to disconnect the motor from the power supply. The disconnecting means must be readily accessible and must be capable of disconnecting all ungrounded conductors of the motor circuit. The NEC provides specific requirements for the type and size of disconnecting means that must be used for different types of motor circuits. In the specific example provided, The warm air furnace has multiple motors, including two 5 horsepower motors and one 1 horsepower motor. To determine the appropriate fuse size for the service disconnect switch, it's necessary to calculate the NCA for the entire unit and then select a fuse size that is equal to or slightly larger than the NCA but does not exceed the maximum fuse size permitted by the NEC. Firstly, the full load current for each motor must be determined from the motor's nameplate. In this case, the two 5 horsepower motors have a full load current of 7.1 amps each, and the 1 horsepower motor has a full load current of 1.7 amps. Secondly, the MCA for the unit is calculated using the formula MCA equals 1.25 times the largest motor's full load current. In this case, the largest motor is the 5 horsepower motor, which has a full load current of 7.1 amps. Therefore, the MCA equals 1.25 times 7.1 amps, which equals 8.9 amps. Thirdly, the NEC provides specific requirements for the fuse size based on the motor's full load current. For motors with a full load current of 100 amps or less, the maximum fuse size permitted is 250% of the motor's full load current. However, since time delay fuses are being used, the maximum fuse size is reduced to 175% of the motor's full load current. In this case, the maximum fuse size for the 5 horsepower motor is 175% of 7.1 amps, which equals 12.4 amps. Fourthly, the total fuse size for the unit is calculated by adding the fuse size for each motor. In this case, the total fuse size is 12.4 amps for the two 5 horsepower motors, plus 1.7 amps for the 1 horsepower motor, which equals 13.1 amps. Fifthly, the NEC requires that the fuse size be rounded up to the next standard fuse size. In this case, the next standard fuse size is 15 amps. Therefore, the recommended fuse size for the service disconnect switch is 15 amps. However, it's important to note that the NEC provides specific requirements for the overcurrent protection of motor circuits. The overcurrent protection devices must be sized according to the NEC requirements based on the motor's full load current, the type of motor, and the presence of other overcurrent protection devices. In this case, the overcurrent protection devices must be sized to protect the motors from damage due to overcurrents. The NEC also provides requirements for the disconnecting means for motor circuits. A disconnecting means is a device that can be used to disconnect the motor from the power supply. The disconnecting means must be readily accessible and must be capable of disconnecting all ungrounded conductors of the motor circuit. The NEC provides specific requirements for the type and size of disconnecting means that must be used for different types of motor circuits. In summary, the NEC provides detailed guidelines for the safe and proper sizing of electrical components, including fuses to protect electrical systems and equipment from overcurrents. It's important to consult the NEC and follow the specific requirements for each application to ensure that the electrical system is properly protected. When working with electrical systems, it's essential to prioritize safety and follow all applicable codes and regulations. Always to energize the circuit before working on any electrical components, and use appropriate personal protective equipment such as gloves and safety glasses. If you are not comfortable working with electrical systems, it's best to consult a qualified electrician. The calculations presented are based on the information provided and the NEC requirements. However, it's important to consult with a qualified electrician or electrical engineer to ensure that the fuse size is appropriate for your specific application. The NEC is a complex and comprehensive code, and it's essential to have a thorough understanding of the code before working on any electrical systems. Remember that electrical work can be dangerous, and it's important to take all necessary precautions to ensure your safety. Always consult with a qualified electrician or electrical engineer if you have any questions or concerns. The information presented here is for educational purposes only and should not be considered a substitute for professional advice. Always consult with a qualified professional before making any decisions about electrical systems. The NEC is constantly updated, so it's important to stay current with the latest revisions. You can purchase a copy of the NEC from the National Fire Protection Association, or NFPA. The NFBA also offers training courses and resources to help you understand the NEC. Working with electricity can be dangerous, so it's important to take all necessary precautions to ensure your safety. Always to energize the circuit before working on any electrical components, and use appropriate personal protective equipment. If you are not comfortable working with electrical systems, it's best to consult a qualified electrician. By following the NEC guidelines and taking appropriate safety precautions, you can help ensure the safe and reliable operation of electrical systems. Remember to always prioritize safety and consult with qualified professionals when needed. This guidance should help you in sizing the fuses for a warm air furnace with multiple motors. Always refer to the latest edition of the NEC and consult with a qualified electrician for specific applications.